Let's talk about the modeling methods and SPSS Modeler. There are numerous algorithms in Modeler, but what we've done and what I'm going to present is divide those modeling methods into 7. Now, before I do, I want to lay the groundwork by talking about the 4 data formats or data structures that you'll encounter. So here's the first one. And once you get to the actual act of modeling, this is generally the most common. So what do we have here? Well, this is tabular data with target. What do we mean by tabular data? Well, take a look. Each row is a customer. Now, certainly, that first customer had to have numerous transactions to get to an annual spend of $10,800, or they probably did. They certainly could have had multiple transactions, but that's been rolled up. It's been aggregated to 1 row per customer. The other thing that's noteworthy about this is the blue column. So what's going on there? We've divided customers into whether they're loyal or churn. So this is something that's happened in the past. They've either renewed or haven't renewed their cell phone contract, for instance. Not all parts of the world have a contract when it comes to cellular phones, but we certainly do in the U.S., usually 24 months in length. And it's big business to try to get folks to renew and stay with the same company at the end of those 24 months. Okay? So what we have in the middle, the green columns, are the variables that might help us predict whether or not they're going to be loyal or they're going to churn. Now on the far left, we have a unique identifier that isn't a predictor per se, but would help us merge this data with other information. Okay? So that's tabular data with target. The whole idea again is that we're trying to predict the blue column using the green columns. Okay? So what about tabular data without a target? Well, this is also tabular. We still have 1 row per customer, but gosh, there's really no variable that feels like a target here. We have a percentage of their spending on entertainment, game consoles, hardware, movies, software, streaming, and video games. Those are all kind of the same. You know, they're all different departments. Certainly useful information to have, but there's nothing that feels special. There's no particular one that we're trying to predict using the other. As I've said already, they're really quite similar to each other. So this is definitely a format that can be analyzed, but you use different approaches when you have this kind of data. Okay? And we're going to be seeing that as we get into the different methods, that there is this general alignment between the methods and the data formats that they require. What about the third one? Well, we've broken the trend, haven't we? Okay? We still have 1 row per customer, or rather, strike that, we have 1 row per transaction. We have potentially multiple rows per customer. Now, you might glance at this for a moment and say, well, you know, I don't see any tangible evidence that we have more than 1 row per customer, but we almost certainly do. If you look critically at this, you'll see that it's sorted by timestamp. So in just 25 rows of data, perhaps there hasn't been an opportunity to have a repeat, but almost certainly customers have more than 1 transaction. And the way that we would convert this into tabular, either with the target or without, depending on our data, would be by aggregating it, by rolling it up in some way. So let's say that we rolled this up, maybe sales amount would be our target. You know, our target does not have to be a categorical variable. Maybe we're trying to predict first 12-month total sales for these different customers. But we would have a hard time doing that with data like this. So there are approaches that you can use directly on transactional data. But it's also very common to transform your transactional data into tabular and then go from there. Okay, what's the fourth one? Well, this is time series data. Time series data is specialized in nature in the following sense. There's one method that is, well, there's a family of methods that's used to do time series forecasting, and you're going to have a hard time doing that without the proper format. You're also going to find that there's not a lot of methods that can be applied to this. There's this one family of methods, complex as it is, but this requires some special treatment. So what's special about this, and what makes it different from transactional? They both have dates after all. Well, these dates are equally spaced. So this is also tabular in a sense, not rolled up to the customer level, but it is rolled up to the date. What we have here is we have total turnover or spend, basically. This happens to be data from Australia for each of those months. And we've recorded the first of the month, but truly you can see it's really the entire month, the month of January, month of February, and so on. Okay, so a specialized data set with a method to match. So now what we're going to do is we're going to start talking about the 7 techniques or methodologies, but we're going to be referring back to these data formats. So let's begin. Let's continue our discussion of the modeling methods. In the previous section, we talked about the 4 data formats that you'll encounter on a predictive analytics project. Now we're going to talk about the 7 methods, and you're going to see a tie-in between the two. One of the 4 data formats was tabular with target. Well, our first modeling method, classification, also called supervised segmentation, must have a target. In this case, the target is credit risk. We have 3 categories: bad loss, bad profit, and good risk. And we're trying to figure out which category a future loan might fall into, a future customer. In what sense is it supervised? Well, as one of my colleagues likes to describe, it's as if a tutor was looking over your shoulder and you guess good risk, and they said, no, not in this instance, that's actually a bad profit. In other words, the supervised aspect is that it can correct you. Well, since we know the status on the historical data, as the model is building, it will learn from that historical data. That's the sense in which we would say supervised. In what sense would we say supervised segmentation? Well, we're dividing the data into different segments. So for instance, node 12 has 2.4% good risk, whereas adjacent to it, node 11 has 55.2% good risk. All of these nodes that do not further subdivide are called terminal nodes or leaf nodes. And if you add up the sample size of all those leaf nodes, you get the grand total. So we have 2,455 individuals. We have subdivided and subdivided again until we stop. And then if you add up all those leaf nodes, it adds up to the 2,455. So that's the sense in which we're talking about supervised segmentation. So that is a classification problem. That is an instance where we have a target, and the target is categorical. So which techniques in Modeler are capable of this? Well, there are a bunch. There's one node that's a bit special. It's called the auto classifier. What it will do is automatically run all of these, tell you which ones are best. And it even has a fancy feature. It will take the top 3 and form kind of a collaboration or committee of those 3 models. That's an interesting topic in and of itself, but we won't explore that further now. But if you go into the expert tab of the auto classifier, it lists all the relevant techniques, all the ones that the auto classifier uses to do its job. Some of them are in the form of a tree, like we just saw. Some of them come from the machine learning tradition, like neural net. And some of them come purely out of traditional statistics, like discriminant analysis has been around since the 1930s, but is still quite effective on finding categories in some instances. Now, it's very, very common that you will have a flag target. By that I mean having just 2 categories, like whether or not you will stay or go at the end of your cell phone contract. But as we saw in the previous example, you can have more than 2 categories. Let's talk about the next one. Well, you don't always have a categorical target. Sometimes you have a scale target. In this case, the scale target is horsepower, and we've arrayed a bunch of cars based upon their higher and lower horsepower. We're also looking at miles per gallon in this example. So we call this numeric prediction, but it's not the only name for it. In Modeler, numeric prediction and classification are all found under the tab classification. We find that can get a little confusing though, so that we've separated them here. Another common name for this would be estimation. Yet another name would be to call them all regression. But again, we think it's a little bit confusing to call neural net a regression technique or CHADE a regression technique. So we favor numeric prediction, and we're just trying to avoid confusion here. Scale targets and categorical targets are quite different, so we put them in 2 different families. If you've really been paying attention, you might have noticed something. Take a look at the symbols here. Take a look at some of the algorithms that we can use for numeric prediction. I'm going to make it easy for you. I'm going to go back. You'll notice some of those same icons, don't you? Okay? So support vector machines, neural net, among others, are in both lists. Well, how can that be? Well, the type node and modeler will know whether or not you have a continuous variable or a categorical variable, and it will act accordingly. Okay? So that's the idea behind numeric prediction. Let's move on to clustering and anomaly detection. What's going on with clustering? Well, in this very simple example, we're looking at the distances between data points. So the red data points are close to each other, so we're going to say that they belong to the red cluster. And the blue data points are kind of on the other area of this chart. So we're going to dub them the blue cluster. And then in the middle, you have this red X. Well, what's going on there? Well, if this was a flat sheet of paper, like this example, in other words, just a flat plane, we might just simply call that the center and be done with it. But clustering is normally done on many dimensions, 8, 10, 12, 15, 20, or more. And so we have a fancy name for the center in this case. We call it the centroid because it's the center of these multiple dimensions, you see. And it's really only under those circumstances that you want to try to use a clustering algorithm. If you only had two clusters on 2 dimensions, you could just simply array the dots in a simple visualization and get out an ink pen, you see. But when you have multiple dimensions, it gets more complicated. So what is the idea of anomaly? Well, anomaly detection first forms the clusters and then identifies that there are certain data points, okay, that are rather far from the centroid, and therefore we say, well, you know, they're just a little bit out of place. They're not quite like the others. So the blue dots that are distant from the centroid are still closer to the center of the blue cluster than they are to the red, but they're just kind of far from the center. What's going on? Well, they could be data entry mistakes. They could deserve further scrutiny for that reason. They could even be fraud. They could even be unusual because of criminal behavior of some kind. Okay? So that's the basic idea between clustering and anomaly detection. In Modeler, we can see that our choices are k-means, Cahonin, and two-step, which are all clustering techniques. Anomaly detection we've already discussed, and KNN stands for k-nearest neighbors. You may possibly recognize this because it was also found in earlier discussions of classification. But it has a feature where it just calculates distances, the same kind of distance that anomaly detection is using. But when you're using KNN to find distances, you're trying to find the data point that is closest to another data point. So, even if it may seem like a trivial example, a website like eHarmony that's trying to match people with a date uses k-nearest neighbors on individual survey results. Kind of a interesting example of KNN. So when you're looking at those distances, clearly you're firmly in the camp of these techniques. So that's clustering and anomaly detection. What about association? Well, back in the previous section, we talked about the 4 data formats. And one of the data formats was transactional in nature. You often don't analyze the transactional data itself. You aggregate it, and then you turn it into something tabular, and then you go from there. But here is a technique that can work right on the transactions. We're basically trying to say, based on people that saw Vanishing of the Bees and the vaccine war, maybe if someone has seen only one of those, they might enjoy seeing the other one. Okay, so this is not based on tags or anything about the content of the movie. The association technique has no idea. It's simply saying that people that watched one seem to have also watched the other one. So when you encounter a customer that has seen only one of the pair, you might recommend the second one to them. So that's the basic idea behind association. In Modeler, here are our options. We can use a priori or karma two algorithms that are capable of this. But then there's a third one that's a little bit different. So let's talk about it. The sequence node doesn't just say if A occurs, B also frequently occurs. It goes one step further and says if A occurs, B is likely to occur at some point down the road. So it puts it into time sequence. One of the many applications of this is web mining, trying to follow their clickstream path. Although a colleague of mine frequently tells a rather interesting story about how this can be used with predictive maintenance. If part A has trouble and then part B has trouble, part C often has a problem as well. You might replace part C even though there is no evidence yet that part C is failing, but because after A and B go, C is usually right behind it. Okay, let's talk about the next one. Let's talk about forecasting. What's going on with forecasting? Well, we mentioned back in the previous section that sometimes we have a data format where every row is equally spaced dates, one row per week, one row per month, and so on. Well, that's exactly the kind of data that we're looking at here. So we have a specialized set of techniques that allow us to predict or forecast future variables of that single variable. Time series forecasting is rather unique in this respect. You can have just one variable in a date, and this technique can predict the variable with itself. It predicts the current and future behavior of that variable based on the historical performance of that variable. Take a look. So here we've got price fluctuations of IBM stock itself, and we can see this up and down pattern. I'm not sure what would cause IBM to be seasonal, and I don't think that's what we're looking at here because we're only looking at 1 year. But there are patterns like this that are seasonal, and that's the kind of thing that time series forecasting is picking up on, is that trend up, that trend down, but also that seasonal up and down, and it's looking at all those factors together. So what are some of the things that are capable of performing this for us in Modeler? Well, the time series node, note, is the only pentagon shape that's visible here on the slide, and that's because it's kind of special. It's really like the automated nodes, auto classifier, auto numeric. It actually will run a number of different techniques on your data and then come back with the best model. Take a look at the data here. So we have different dates, monthly data. We could forecast just the total. We could forecast market 83 or market 84 or market 85. We could look at those columns one at a time. We could even throw them all in together and it would come up with 4 different forecasts. So that gives you a little bit of an idea of what's going on with time series forecasting. Now let's talk about text mining. This is a little bit of a funny example, just kind of a lighthearted example. This is from Yelp. This is a barbecue restaurant that's not too far from my adopted home in North Carolina. But I don't want you to think that something kind of trivial like this is that all that text mining can do. Text mining is such a powerful technique that increasingly predictive analytics professionals are specializing it, and sometimes all they do is text mining. What is really amazing about text mining and Modeler, and what we've had tremendous success doing, is extracting the information out of the text, but then sending it to another model, like a classification model. And that's what's so powerful about Modeler. Modeler has the text mining algorithm living right inside Modeler along with the other algorithms, so the results of the text mining can actually turn out to be a data prep step for other kinds of modeling techniques in Modeler. But let's take a little look at what's going on here. Well, a number of folks, 44 apparently, have mentioned barbecue. So up at the top you see BBQ, and then down at the bottom you see barbecue spelled out BARBECUE. Okay? So one of the things that text mining can do is find out that those two are referring to the same thing. But gosh, that's awfully trivial thing for text mining to do. That's just a very small part of what it can do. The other thing, of course, that you might know about text mining is it can detect sentiment. It can figure out that someone has said something favorable or something negative. So for instance, you could try to find out what are some of the things that are negative that even people that gave 4 and 5 star ratings said. That kind of thing, right? You could pick up on some negative phrases. So text mining is a whole huge topic, but what you're basically doing is converting unstructured data to structured data. You could send that structured data to a basic report, or a lot more exciting, you could send that unstructured data, convert it into structured data onto another model, and have that new structured data become inputs in a predictive model. Let's take a look at the inside of Modeler as it does this. So down at the bottom you can see that there's a lot of highlighting going on. That's because one of the things that Modeler is trying to do is pick up on trends or categories and then convert them into new variables. So accessibility seems to be one of the things that people were talking about these renter cars. The car was ready for me on time, and on time is highlighted. You notice that there's a smiley face up by upgraded or no wait. So we can make a connection between categories and sentiment. Then eventually all of these become categories in the data set. So for instance, we can find everybody that said customer support and positive, and they will get a true, and those new variables will be sent out to the data set where they can be used as inputs into other models. And that's what's really exciting about doing text mining in Modeler, is that for me, when I'm doing a text mining project, I want to reach the analysis of the text about halfway into my allotted time so that I can spend the second half of my time using that new information in my predictive models. Here's a little bit more, including the nodes that can be used to do this. So we have one pentagon symbol up there, but that really feels almost like a little software package inside of Modeler. It has lots and lots of features, but then we have supporting nodes as well, like the web feed node could help us go out on to read blog pages, for instance, and find out what people are saying about our product line by pulling things in from the web. Now let's talk about the final one. Let's talk about entity analytics. Fascinating, fascinating topic. This was produced by, or invented, developed by a gentleman named Jeff Jonas and his team at IBM. You may want to seek out some videos of Jeff Jonas describing entity analytics. They're quite entertaining, very informative as well. So what are we looking at here? Well, we're looking at 3 different data sources, and those data sources have identified what at first appears to be 3 different entities. Entity 102, 343, 642. Now, as humans, we can look at this and almost immediately see that something funny is going on here. We can see that Beth L. Doe Smith, Liz Doe, and Elizabeth Lisa Doe look like they've got a lot of similarities. Well, even though that's easy for us to see on the slide, try doing that with 10 million records. That would be really, really hard. And that's, of course, why we have entity analytics. So what's the utility of this? Well, one thing that could be going on is maybe that a bank has just merged with 2 other banks. So now you have this larger company, and we don't know that our retirement plan for Liz Doe is the same Liz Doe that has her checking account as Elizabeth Lisa Doe. Why would that be interesting? Well, we can't engage in upselling or cross-selling if we think that she is 2 different people. Okay? Not only that, she may not feel like she's being treated all that well, because whenever she calls in, whenever she refers to the retirement plan to the checking team or vice versa, there seems to be confusion, like they can't find her. That kind of thing can be frustrating. Now, in this instance, though, I think you can detect that that's not what's going on here. It just seems a little funny. We've got the multiple addresses. This could actually be on purpose this could be fraud. It could be that Liz Doe has engaged in a bit of insurance fraud and done 3 different insurance claims, and she's pretending to be 3 different people, because if we knew that she had 3 different claims within a 90-day period or 180-day period, that immediately might trigger a flag. So she's trying to disguise herself. Okay? Very interesting topic. So what does it look like inside of Modeler? Well, we have 3 different nodes that together are related in this activity. And I love the icons down at the bottom there, because this kind of puzzle pieces that are arrayed on a table, you could imagine, in the observation space, then are found to fit together. Very, very interesting stuff. Entity analytics was successfully used, we think, for the first time by a Qubit team on a fraud project just a couple of months after it came out in version 15. Very good ROI on that project. Very exciting stuff.